One of the key components in a sequential circuit is the latch or the flip-flop. So I'm going to start by explaining those circuits, then I'll move on to examples of sequential circuits, followed by examples of finite state machines. So here's the most basic latch that you can design. It's referred to as the S-R latch. It has two signals, R, which refers to a reset, and S, which refers to a set. And it has an output, which is Q. Now, if I make reset equals 0, and if I make set equals 1, this circuit is supposed to set the output value to be a 1. So let's confirm if that indeed happens. Okay, let's look at this NOR gate over here, right? So the circuit is basically two NOR gates, where the outputs of each of the NOR gates serves as one of the inputs to the other NOR gate. So if you look at the bottom NOR gate, one of its inputs is now a 1. I don't yet know what this other input is going to be. Let's just call it X, right? It could be 0, it could be a 1. Now, if I make X and 1 go through an OR gate, X plus 1 is going to give me a 1. And then I invert that signal. So that produces a 0 over here. That feeds in as one of the inputs to this other NOR gate. The other input of that NOR gate is the reset signal, which is being made 0. So the OR of 0 and 0 gives me 0. Once inverted, that gives me a 1. Okay, so indeed the output has become a 1. Let's just kind of complete this loop over here. This comes back as input here. It doesn't change anything because I said that regardless of whether X is 0 or 1, the output of this NOR gate is going to be a 0. Okay, so this circuit is in a stable situation. When set is 1, reset is 0, the output Q is made 1, and the other output Q bar is just the inverse of that. That's going to be a 0. Now, if I change the signals, let's make reset equals 1 and set equals 0. When I do this, the exact opposite happens. Q becomes 0 and Q bar becomes 1, right? So I won't go through the exact details, but you will see that in the circuit, the top half is just a mirror image of the bottom half. So if I flip the inputs, the outputs are going to flip as well. Okay, now let's look at the other two cases when both the reset and the set signals are 0. Okay, let me clear out the screen first. Let's say that set was 1, reset was 0, and correspondingly Q was 1. Okay, now I'm going to transition and I'm going to bring that set signal down to a 0. I'm going to bring the reset signal, well, it's going to stay at a 0. And my question is, what happens to Q? Okay, so set is now 0, reset is 0, Q used to be 1, and now let's kind of go through this chain of logic to see what happens. Okay, since Q is 1, this input over here is a 1, this input is a 0. When I send it through a NOR gate, I'm going to get a value of 0 over here. That feeds as input over here. The OR of 0 and 0 is 0. Once inverted, that gives me a 1. Okay, so this is going to be the stable outputs of the circuit. So what it tells me is that Q is going to be a 1. Now let's take one more case. Let's take a separate case altogether over here, where S is 0, reset is 1, and we've already seen that Q is now going to be 0 in this case. Now if the set signal remains at 0 and the reset signal is brought down to 0, the question is what happens to Q. Okay, so let me erase all of this here. And so I know that Q is 0, this is 0, this is 0. Right? So if I look at the bottom NOR gate, its two inputs are zeros, and so the output over here should be a 1. That feeds as input here. The OR of 1 and 0 is 1. Once inverted, that gives me a 0. Okay, so that tells me that the value of Q is now going to be a 0. So you'll see that this case over here and this case over here are actually different. The inputs are the same. The input S is 0, the input R is 0, but in one case the output Q is 1, and in the other case the output Q is 0. Right? So this is not entirely a combinational circuit in some sense. What the circuit is doing is it's remembering the last value of Q. Right? Previously Q had been 1, and so the output remained 1. Previously the value of Q was 0, so the output remained 0. Right? So essentially, when the inputs S and R are both made 0, this circuit is in a remember state. That means it remembers what its last output value was, right? So now we have essentially constructed a memory element that can remember what its last state was. Okay, so if R is 1 and S is 0, then we are in the reset state where we are resetting the output to 0. If S is 1 and R is 0, we are in the set state where we are setting the output to be a 1. And if the inputs are both 0 and 0, then we are in this remember state where the output is whatever the last value of the output was. There is a fourth case where both R and S are high. And when you do this, you will see that the output is unstable, right? Essentially, the values keep toggling back and forth. And so this set of inputs is viewed as an invalid input. Okay, so at most, I can have one of these inputs being high. And when both the inputs are low, then I'm in this remember state, right? So the latch is one way for me to construct a memory element.